Let's take a look at example number 5 here. It's y equals, and it's x cubed over x minus 1. And to graph this one, again, we have a domain restriction. X cannot equal 1. And let's see, are there any holes? Nope, there are going to be no holes because, again, nothing cancels, so no holes. So that means our domain restriction, that vertical has to be our vertical asymptote. And again, it will be M1. To find out if there are any horizontal asymptotes, remember we look at the degree on top and we compare that with the degree on bottom. Degree on top is 3, bottom is 1, it's greater than, so there are no horizontal asymptotes, which means of course it won't cross either, right? Nope. Now, so we're done, so now we're going to get our slant asymptote. Remember, to get the slant asymptote, we divide. We take that x cubed and we're going to divide it by x minus 1. So I'm going to put out a few little x's here, 0x squared plus 0x plus 0. And how many times do I have to multiply by to get x cubed? X squared. So this becomes x cubed minus x squared. Simplify, this becomes just x squared plus 0x. What do you have to multiply by? So plus x. And when we try this one here, let's see here, we're going to get x squared minus x. So again, I get plus x plus 0. And I'm going to go plus 1. And there's our our slant asymptote. Now it's kind of weird because if you notice, our slant asymptote this time is a parabola. Okay, and that's going to cause us a little bit of trouble in just a few moments. Is a parabola, and that's going to cause us a little bit of trouble. So let's go ahead then, quickly get the y-intercept. Very easy. Let x equals 0. We get y equals 0 cubed over 0 minus 1. So it's just 0, 0, 0. Get your x-intercept. Let y equals 0. 0 equals x cubed over x minus 1. Cross multiply, x cubed equals 0, x equals 0. Alright, so now we're ready to sketch this one right now. Okay, this one now. Be very careful because of our slant asymptote. Alright, so what do we have here? We list out our asymptotes. We have x equals 1, y equals x squared plus x plus 1. We also have our point. Now we only have one point where it crosses, 0, 0. So when we sketch this graph here, we know it crosses at 0, 0, and we have an x at, there's our slant asymptote right here. And when we graph this one here, let's see here. Our slant asymptote is going to be a little bit trickier to do. We are approaching, we know the graph is going to cross here at the 0, 0. So our slant asymptote is at 1, it's going to be parabolic, right? So when I go over here, it's going to cross up here. So there's my slant asymptote. So how does this graph look? Well, remember, there's an asymptote here. So my function is going to go down this asymptote on this side right here. So in between here, the asymptote is really not affecting our graph any. It's when we go up to the other side. It's going to go up, and then it's going to follow the asymptote. And on the other side, where is it going to be? Well, up here. And actually, and then it's going to curve up right here at the very end. It will wind up curving up. So the outside is going to follow the asymptote. Now this one's a really tough one right here to do, so try this one more time before you go on to number 6. All right, and we might probably go over this one again tomorrow too, okay? All right, so let's take a look at number 6, our last one. Now we are changing up the problem for number 6, so make sure you write this one down here. Number 6 is we're going to rewrite this as the equation y equals x cubed minus 1 over x squared minus 4. Because again, this is kind of one of those, another weird one with a little type of, different type of asymptotes and everything. If I were to factor it, the top here doesn't factor very nicely for us. So it becomes x minus 1, and I get this x squared plus x plus 1. It's our difference of cubes. The bottom, x plus 2, x minus 2. Nothing cancels, but we do have our domain restrictions. X cannot equal 2 or negative 2. Are there any holes? Absolutely none, because nothing canceled. So that means we have two vertical asymptotes, and they are both M1. Get the horizontal asymptote. The degree on top is bigger than the degree on bottom. And that is because 3 is bigger than 2. So there's no horizontal asymptote. So let's go and get the slant asymptote. We already know it's not going to cross. So let's get the slant asymptote. We have to divide. I'm going to take this x squared plus 0x minus 4 and divide that into x cubed plus 0x squared plus 0x minus 1. And I've already done. Find the slant asymptote. We have to multiply here by x. That becomes x cubed plus 0x squared minus 4x. And we change that, becomes a positive. These just go away. So we get 4x minus 1. Now, this is my remainder. Remember, we don't really care about the remainder when you're finding a slant asymptote. So the slant asymptote, just y equals x. Get your x-intercepts. Your or let's go and get the y-intercept first. Get the y-intercept. Take a look at your equation. Basically, if you let x equal 0, you're going to get negative 1 over negative 4. So we get 1/4. So your y-intercept, 0, 1/4. Getting your x-intercept, I know I'm like all over the place here. Let y equals 0, and you're going to get x cubed minus 1 over x squared minus 4. Now, when we cross multiply, that goes away. So we get this. Now, we've already factored this x minus 1, and we get x squared plus x plus 1. And we only, if you notice, we only get 1. That's actually going to be imaginary, because if you try to use quadratic formula, x equals negative b plus or minus square root b squared minus 4 times 1, that's imaginary. We don't care about that one. So the only x-intercept we have is that 1. And now we're going to list out everything to graph it. List out your asymptotes. They are plus or minus 2 and y equals x for your slant asymptote. Any points there we have? 0, 1/4 and 1, 0. And I kind of ran out. I should make myself more room. So we'll graph it in here. We're at negative 2, positive 2. And now, how I do the slant. Now, the inside's a little bit different, but how I do the slant, very easy. It's going to be the line y equals x. So it's going to be like here. But the problem is, in the middle, is something different. So my slants only affect outside of my graph. I graph my 1 points that I have, 0, 1/4, and 1, 0. So what has to happen on the inside is it has to go down the asymptote right here. It just follow the direction. And never crosses the x again, so what does it mean? It must go up. And since this is M1, if this goes down, the other side goes up. Because this is also M1, if it goes up, the other side must go down. And there's your graph. You have 1, 2, 3 different regions. So try these two again, and we'll take a look at these tomorrow. Thank you.